Thank you for showing up and being part of part number 5 of lecture number 25, our last lecture in this series on engineering mathematics. And we're ending with line integrals. This example, we would like to find the work done by the electric field, the E field, minus xi minus yj plus zk, on an electron moving from 1, 1, 1 to 2, 2, 2 along the path. And what is the path? The path is x equals 1 plus t times the sine of the pi over 2 times t. And y equals t plus the cosine of 6 pi t. And z equals 1 plus t squared. Okay, so this is the path. Okay, this path is not looking too good, so let's see if we can use what? The curl. We just talked about the curl, so let's see if we can use the curl here. Okay, so if we're going to cross the E field, we cover it up, and guess what we get? We get 0. Okay, if we cover up I, right, we have the partial of z in reference to y. Okay, that's 0. We take the partial of a minus y reference to z, that's 0. Now let's look at j. Cover up j, we get the partial of z in terms of x is 0. We look at the partial of minus x in reference to z is 0. And then we look at the last one, the k one, and we see the partial of minus y is x is 0. And we see the partial of minus x in terms of y is 0. So that all equals 0. Wow. So since the field is conservative, we just looked at that, we can pick a different path. Okay, we said that the paths are independent. We can choose any one we want. So now the only problem with this one is when you have the sign here, okay, you're going from what? 0, 1 to 2. Okay, so going from 1 to 2, that's not good in reference to our pi here. Pi over 2. 6 pi, since it's always going to be even, 2 pi and so forth, 0. This will be fine because the cosine of any number like that, any even the number of pi, is always going to be like it's 0. So it's always going to be 1. Okay, so this is going to be like, you can replace this with 1, t plus 1. And you have z plus t squared. Now this is the tricky one. You have pi over 2 times t. If you take, gotta be very careful. If you take t at 0, what do you get? Sine of 0, right? Get the sine of 0, so x equals 1. Now if you plug in that 0, 1, your pi over 2. That's 90 degrees. Okay, so you have to sine at 90 degrees is 1. Okay, so that'll be 1 plus t. Now, okay, so It's just like a sine wave that keeps going up and down. It'll be 0, then it'll be 1, then it'll be 0, 1, 0, 2. So this one's going to be very confusing. So at this point, we're 5 minutes in, and so we just wanted to let you know that you can pick a different path. Thank you for being part of our series. And we look to see you next year, or next semester, or whenever you need to study engineering mathematics. Thank you.